Section 3.3 is on systems of inequalities. A system of inequalities is two or more inequalities that are considered together. The solution is the set of values that make both inequalities true. One way to solve a system of inequalities is to use a table. So here's our first example. It says assume that x and y are whole numbers. Use a table to solve this system of inequalities. So I've started to set this up a little bit here. So we have x plus y is greater than or equal to 5, and 2x plus 3y is less than or equal to 15. To be honest, using a table is not the most efficient way to do it, but I'll show you the steps in case you're interested. So you want to take the more complicated inequality, which would be the second one here. 2x plus 3y is less than or equal to 15. I want to find all of the values, all of the pairs of x and y that work in just that inequality. Okay, and since it says x and y are whole numbers, we're going to start with 0, and in this case it happens to go up to 7. We could go a little higher, but we're just going to stop right there. So when I plug in 0 for x, what are the values of y that are possible? So when x is 0, okay, I end up with that goes away, and I just have 3y is less than or equal to 15. So what can y be? Y can be 0, it can be 1, it can be 2, it can be 3, it can be 4, it can be 5. It can't be 6 because that would give me 18, which is not less than or equal to 15. And we kind of continue through and do that with every other number. So I put in, and remember I'm going for the second one, 1 in for x, so that gives me 2 plus 3y is less than or equal to 15. And subtracting 2 from both sides, 3y is less than or equal to 13. And the values of y that would make that true are 0, 1, 2, 3, and 4. Notice I can't do 5. Okay, so I'm going to take a pause here and go ahead and fill in the rest of this table. So I've gone ahead and completed the table here and found that for these given values of x, these are the possible y's that would make the second inequality true. Now what I need to do, and think of each of these as an ordered pair. So this would be like 7, 0, 6, 0, 6, 1, and so on. Now I need to figure out which pairs of numbers here make the first inequality true. In other words, when I add x and y, do I get a number that is greater than or equal to 5? Okay, so when I add 0 and 0, I get 0. 0 and 1 doesn't work. 0 and 2 is not greater than 5, but 0 and 5 is. So that gives me one of my solutions. So the ordered pair 0, 5 is a solution that would work for both of these. Now when x is 1, the only one that's going to work there is 4. So 1, 4 is a solution to both inequalities. When x is 2, the only one that's going to work is 3. So that gives me 2, 3. Now when x is 3, 3 plus 2 gives me 6, so that'll work. 3 plus 2 gives me 5, that'll work. 3 plus 3 gives me 6, so that gives me the ordered pairs 3, 2 and 3, 3. For 4, 1 will work because that gives me a 5, and 2 will work. So 4, 1 and 4, 2. And for 5, both 0 and 1 work. So 5, 0, 5, 1. And the same thing for 6. When I add the x and the y, I get a number that's greater than or equal to 5. So 6, 0, 6, 1. And the last one, 7, 0, also works. So that's kind of a tedious way to solve a system of inequalities. Another way you could do it is by graphing, which we'll take a look at in the next example, but I'll give you a little sneak preview here. So here we have a little first quadrant of the coordinate plane, and my first inequality, which was x plus y is greater than or equal to 5, I can graph that pretty easily using my x and y intercepts. That would be a point here at 0, 5, and a point here at 5, 0. So that would be this line right here. It has a slope of -1. Okay, so I'm going to be looking for values that are above that, so I would be like shading kind of up above here. I'll do a little bit of shading there. My other inequality, which was 2x plus 3y is less than or equal to 15. Solving that for y gives me y is less than or equal to -2/3 x plus 5. So the same y-intercept here of 5, but down 2 and right 3. Down 2 and right 3. Or if I go down 1, I could go right 1.5. That'll give me a couple intermediate points there. Okay, and that is this line right here. And since I'm looking for less than or equal to, that's going to be below that line, so it's going to give me this region in here. Now, remember we were just looking for whole numbers, so we'd be looking for any of these points here. And actually, I can't use that one right there. I can't, because that's a half, and I can't use that one because that's a half. But this one as well, this one as well, and then all of the points, places basically where the grid lines intersect each other on the inside. And that's going to give me the 12 points that I had in my previous one. Oh, and actually I forgot these down here too. Those work as well. Okay, so using a table to solve a system of inequalities, I wouldn't recommend it. But graphing is actually a really useful way to do it. And let's take a look at another example here. So here we have a system. Y minus 3x is less than or equal to negative 4. Right away, I'm going to change that into y is less than or equal to 3x minus 4. And that's going to be a solid line. And since it's a less than or equal to, I'm going to shade below. This one is already written in y equals mx plus b form, and this is also going to be solid. And I will be shading above. I always like to write that out so I can keep things straight. So let's go ahead and graph that. So the first one, negative 4, up 3 and right 1, or down 3 and left 1, gives me a line like this. Solid. And I'll be shading below where the y-axis is below, so kind of here. I'll just do a little bit to remind me. My second line is a y-intercept of negative 3 and a positive slope of positive 1. So that's going to look like that. Go ahead and draw that line in. Okay, and this one I'm going to be shading above, so up here and up here. And now comparing my two shadings, it's going to give me this region in between the lines right here. So what does that mean? So that every point in there, and like our previous, not like our previous example where we were only looking for whole numbers, but actually every fraction, every decimal in there are ordered pairs that will work in both of those inequalities. Let's take a look at a word problem here. Tickets to a concert cost $70 or $20 with a student discount. It's a pretty good student discount. Ticket sales must exceed $500,000 for the group to perform. If 20,000 seats are available, how many of each type of ticket must be sold? So from this information, I can write a couple inequalities. Let's start by defining our variables. Let's say, let x equal the number of regular tickets. And let's let y equal the number of student tickets. Now I know right away that there are 20,000 seats available. So the number of regular tickets plus the number of student tickets has to be less than or equal to 20,000 because that's how many seats there are. Let me move this down just a little bit more here. Okay, now I know that regular tickets cost $70. So that's the amount of money they'll take in for the regular tickets, plus $20 for each student ticket, and I need to make at least $500,000. So that has to be greater than $500,000. Okay, I'm going to graph these two inequalities. The first one's not too bad because I'm going to use x and y intercepts, but let's turn this one into slope-intercept form. So subtracting 70x on both sides and dividing by 20. Let's see, that's 25,000. Okay, let's go ahead and label our axes here. So I'm going to do, since I chose x to be regular tickets, so this is going to be the number of regular tickets. And that's going to be in thousands. Okay, and I think I'm going to go with 5, 10, 15, 20, whoops, sorry about that, and 25. Over here, I'm going to do my number of student tickets since I chose that to be my y. And again, that's going to be in thousands. label it similarly. 5, 10, 15, 20, and 25. Now my first inequality, x plus y equals 20, my x and y intercepts are each 20, 0 and 20. So that's going to give me a dot here and a dot here. And I can just draw that line. That's going to have a slope of -1. If I can go through the boxes, that's pretty close. And my shading is going to be below that line since it has to be less than that. For my second inequality, my y-intercept is 25. And I'm going to go down 7 and right 2. Did I do that right? 2, 4, 6, 7, and 2. And I'm going to run out of room down there, so I'm just going to have to eyeball it. That's going to look something like this. Okay, I think that's about right. And I need to have more than that, so I need to have shaded above that line, which means that my shaded overlap of the shaded areas is going to be right in between here, in that area right there. Okay, so this inequality represents the number of tickets that have to be sold for this concert to go. So any combination of x and y in here. So for example, let me just pick a random point. How about this one right here? So that refers to 10,000 regular tickets and 5,000 student tickets. So one possible answer, so I'm going to say, for example, if you sell 10,000 regular tickets and 5,000 student tickets, the concert is a go because you have enough people to fill, people to fill the seats. You don't have more than 20,000 tickets that you've sold, and you will be making enough money for the group to perform. So there's actually a whole lot of different answers in here, anywhere in here, and probably even in between. Any value in there is a possible combination of ticket sales that's going to work for this event to happen. And our last example is a system of inequalities that can also include nonlinear inequalities. In this case, we have an absolute value inequality. So let's see, this one, y is less than or equal to -3 times the absolute value of x plus 3 plus 1. So that's going to be dashed and shaded below. And I can figure out a little bit about what's going on with this absolute value. I can tell that my vertex is going to be -3, 1. Because my A is negative, it's going to be opening down. It's going to be upside down. And the slope of the right-hand side is going to be -3. So the slope of that side right there is going to be -3. So let's go ahead and graph that. That looks like fun. So -3, 1. And that slope is going to be down 3 and right 1. And let's mirror that on this side. Actually, it's down 3 and left 1 on this side. That's dashed. I'll throw a few dashes in there. Okay, and I'm going to be shading inside there. I'll just keep that in the back of my mind for now. Second inequality here is going to be solid, and I'm going to be shading above. My y-intercept is -5, and my slope is -1, which looks like this. Okay, I'll go ahead and draw that line. This is kind of weird the way they run into each other. And I'm going to be shading above that. So I'm going to be shading above this line and inside the V. So that means it's this region in here that ends up getting shaded. Kind of a funky little scaling triangle in there. Okay, so in this section we took a look at systems of inequalities and how to solve them by using a table, which is not recommended, and how to solve them by graphing, where you draw two lines or a line and perhaps something like an absolute value graph and see where the shadings of those two inequalities overlap each other.